So we're going to continue to solve quadratics by factoring today, just like in our last video, but in the last video all the equations were already equal to 0. Okay, so they were in the standard form, ax squared plus bx plus c, where the terms were in descending order by their exponents. Today, they're not going to be equal to 0. We have to make them equal to 0 first. So we want to see equals 0 in the problem before we start solving by factoring. All right, so in example 1, we have equals 15, but we don't want equals 15, we want equals 0. So to get equals 0, we're going to subtract 15 and get rid of it from the right side, so we have to do that on the left. Now I notice there isn't another just whole number, something without an x. So it has no like term. So I'm just going to put minus 15 anywhere, and when I go to rewrite them, put them in descending order. So x squared first, plus 2x, and then minus 15, it's the constant, the one without the variable, equals 0. Once it's equal to 0, we're ready to factor. Okay, so let's practice factoring here. So we're going to multiply to get x squared. So that's x times x will give us x squared. Now we're going to try to multiply to get negative 15. So we have to think about all the things that multiply to get negative 15, like negative 1 and 15, and let's see what else, negative 3 and 5. We can change which one's negative. We can change the order. Okay, so let's try negative 3 and 5. Negative 3 and positive 5. All right, so the inners are negative 3x and the outers are positive 5x, and when you add those together you do get positive 2x, so it worked. Okay, so now once it's factored, you set each factor equal to 0. So I ran a space, so I'm going to put it to the right, so x minus 3 equals 0 and x plus 5 equals 0. We solve each one and those will be our solutions. So we add 3 to get x equals positive 3. There's our first solution. And we subtract 5 and get x equals negative 5. That is our second solution. And we can actually check our answers by substituting them in for the x's and see if they work. So in our equation, if I check 3, if I put in 3 squared plus 2 times 3, and I check to make sure it equals 15, well, let's see, 3 squared is 9, plus 2 times 3 is 6, so 9 plus 6 is 15, it works. I could try putting in negative 5 squared plus 2 times negative 5, and check to see if that equals 15. So negative 5 squared is 25, 2 times negative 5 is negative 10, so 25 minus 10 is 15, and it works. All right, so let's keep solving by factoring. If I notice I don't have equals 0, so I need to make it equal to 0. So that means I need to get rid of this negative 16c, so I'm going to add 16c. If it has a like term on the other side, we put it directly underneath, and it does. And I need to get rid of the plus 2, so I'm going to subtract 2, and again, put it under its like term if it has one. All right, so these cancel, and we get 0 there. So I write it in standard form. 3c squared, negative 14c plus 16c is positive 2c, and positive 1 minus 2 is negative 1 equals 0. All right, once it's equal to 0, we factor. Okay, so I'm going to try to multiply to see what gives me 3c squared. So 3c times c is 3c squared. And now I'm multiplying to get negative 1. So let's see, negative 1 times positive 1. Let's see if it works. Negative 1c, 3c is positive 2c. Okay, so that works. Let's see, now set each one equal to 0. Alright, so now I'm going to add 1. So 3c equals 1, and divide by 3 because c is not by itself yet, so c equals 1/3 is one solution. Subtract 1, c equals negative 1. There's our second solution. So we have two solutions for this equation. That's pretty common in quadratics. All right, for example 3, again, I can Not solved by factoring unless it's equal to 0. So I need to subtract 24a. I don't see a like term, something with just a, so I'll just kind of put it here anywhere, maybe in the middle, and then put it in standard form. So a squared goes first, minus 24a plus 144, and that's equal to 0 now. And we're ready to factor. All right, so a times a is a squared. Now we're going to multiply to get 144, so you might not come up with those very quickly in your head, but go ahead and pause the video and make a list of all the things that will multiply to get 144. So in your list, right, you might have come up with a really long list, and then we're going to try them to see what works, and we need to try to get negative 24a in the middle. So I tried positive 12, and positive 12 gives me positive 144. And when I went to check it, I got positive 12a. Positive 12a gave me 24a. But I realized that I needed negative 24a and not positive 24a. So when that happens, the trick was just switch or change the signs. So both these positives should now instead be negatives. So now negative 12a and negative 12a is negative 24a. So now it works. So set your factors equal to 0. And I'm noticing that my two factors are the same. So when I go to solve and I add 12, a equals 12 here. And if I go to do that on the other one, I'm going to a is 12 again. So this one only has one solution. No reason to write it twice. So there's only one solution for this problem, one number that makes it equal to 0, or I'm sorry, that makes it true. All right, so our last problem, again, we're solving by factoring. We need to make it equal to 0. So I need to subtract 14x, and I don't see another term with just x. So I'm going to write it, but I can't combine these. They're not like terms. So I keep 2x squared. I keep minus 14x, and I'm noticing there's no constant. There's no number here without an x. But it is equal to 0 like it's supposed to. And because it doesn't have our three terms, our trinomial, without that constant term at the end there, I'm not going to be able to use those two parentheses. But hopefully if you look at both terms and you see if they have something in common, you'll notice the greatest common factor. Let's see, what number goes into both? 2 goes into both, and they both have the variable x. So I'm going to take out or divide out the greatest common factor of 2x. So 2 divided by 2 is 1. X squared divided by x is x. Minus 14 divided by 2 is 7. And x divided by x cancels. Equals 0. So we factored it, just not the trinomial. It wasn't a trinomial to factor. Instead, we took out a greatest common factor. So now set each factor equal to 0. So I'm going to divide by 2. So x equals 0 is one solution. So 0 would make this true. And in the second one, I'm going to add 7. And I don't need that 1 in front of x. 1x is just x equals 7 is my other solution. So those are two numbers that make this equation true.